Good day. Today I'm going to discuss a quick overview about the on-the-job training experience at Signix Design Consultancy and Services Incorporation. I'm Nicole Ansi Thomas from ECE3. Content overview of the presentation is first the company profile, next is the OJT activities, and lastly, the technical and soft skills learned during the whole training. So first is about the company. Signix Semicon, based in Alabang, is a pioneer in IC design solution. The company began as a small group of 9 dedicated individuals who worked as engineering experts in the integrated circuit industry. With more than a decade of experience in the field of custom analog and digital design, Cynix has developed into a world-class service provider by serving its client with scalability and access to highly qualified Filipino engineers. So their mission is to ensure utmost quality and personalized solution for lifelong strategic partnerships with their clients, cultivating scalable talent on demand. Brief history about Cynix is Cynix Semicon started at 2009, and by 2011 they have established the Cynix design. Those two are different entities but they have worked in one management. So as stated earlier, they started with 9 employees and as of today they are now 215. To know more about their history, their services, and their goal, you can visit their website. For the OJT activities, the first and second week, it was a discussion period of the different lessons that are essential on performing laboratory tasks regarding designing different circuits. So the week 1 lecture topics are the basic electronics, CMOS operations and fundamentals, digital electronics, and amplifiers. For week 2, the lecture topics focuses on the different amplifier circuits such as the differential amplifier, operational amplifier, current mirror, and comparator. And for the laboratory topics and activities, it started with the Unix and Linux OS, the working environment, and the different commands. And for the simulation tools, we have utilized the HPICE and custom compiler because these two are the ones being used in the industry today. So for the first hands-on activity, it is the simulation of the inverter circuit using the HPICE. So it started with the generation of different netlists with different conditions, and with that, different parameter values and waveforms have been obtained. With this output, the relationship between such parameters such as temperature, switching point, delay, and many more have been known. With that, the characteristic and behavior of this inverter circuit have been understood. Same procedure for the next hands-on activity, but this time it is a NAND circuit. For the third hands-on activity, we have used the custom compiler, and the simulated circuit was an operational amplifier. So it started with building the inside of the op-amp by um, connecting different CMOS, then symbols have been generated, and after completing the circuit, 10 analyses have been performed. With those, it resulted with different waveforms and parameter values such as slew rate, delays, and many more. With those output, we have concluded the relationships and the behavior of the whole operational amplifier circuit. And again, same as the previous hands-on using custom compiler, but this time it is about the comparator and comparator with Schmidt trigger. Same procedure, and we have designed the inside of the comparator, have run different analysis, but the difference between the previous one is that the analysis of this laboratory activity is separated by every analysis compared to the previous one, all analyses are located in one test bench. So the technical and soft skills learned first is problem solving and analyzation skills. Since the training started with lectures of fundamental concepts and theories, it refreshes the knowledge of the trainee from previous courses, and more importantly, it clears and deepens the understanding about every topic. The problems given by the trainers were more complex, thus enhancing our analyzation on what approach is most suitable on every configuration and how to solve it much easier. It improves our thinking on the or critical thinking on the problems that were on different conditions. So next is the Unix/Linux skills. It enhances the skills in programming with this environment and understand the function of different commands that are useful in the industry today. So the third skill is simulating skills using HPICE. Compared to other simulation tool, HPICE was quite different since a netlist must be first generated that corresponds to the schematic circuit, and it is used by coding such commands on a terminal. Creating netlist comprises of different command lines that specifies connections, conditions, measurements, and a lot more. Therefore, it refines our knowledge and skills on creating netlists and analyzing the output waveform. And lastly, the simulating skills using custom compiler. Using custom compiler as a simulation tool was new for us. It is also one of the tools used in the actual industry in microelectronics. As a result, trainees learned how to use it in different tasks and navigate it smoothly since there are different activities that must be accomplished using it. From creating symbol up to performing various analysis, the skills continuously grow and improve. So that's all. Indeed, it was a great experience. It gave us an edge on the future by acquiring new skills in designing. Thank you.